Good day, everyone, and welcome to my YouTube channel, Charot. Today we are going to discuss the answers and, of course, how to solve the compression members exam nato last week. Without further ado, let's start. Now, given the thrust loaded as shown in the figure in the right, member BC is a hollow tubular section. So, yung figure is actually something like this. Hollow, dapat ma-visualize ni mo daan before ta mo actually solve sa problem, no? So it's a tubular section inan murag donut. Okay. So going back, it has an outer diameter of 50 and a thickness of 10 mm. Later on, ato na i-image visualize ha. And we have FY290. Okay, and then we're asked to find the following: find the actual compressive stress of member BC, find the allowable compressive stress of BC and ASD, and the design strength of member BC for LRFD. Okay, so before we actually solve for this, we need to always write down the given. The given may kato mga obvious one, which is naadira gisulat. So write down Fy equals 290, and the other one is actually the area. Although it's not stated there explicitly, we can solve for the area. Do not solve yet. At least you know nga ma-find out that ang area. So just keep that in mind. Okay. Now let's do the actual calculation for number one. So the question one is find the actual compressive stress of member BC. So before you solve, make a plan. So we are asked to find the actual compressive stress. Now, to solve for the compressive stress, we know that compressive stress is equal to the load over its area. Now, we know for a fact that um, we need to solve for BC first, the load, the actual load that BC carries over its area. Okay, di ba sa given na to, na area, correct? And BC, so wala pa ta. So muna siya atong unang solvon di ay. We need to solve for BC sa load BC or the actual load that BC carries. Now to solve for that, we are going to use the method of suction. So we are going to cut around here. Now, once we cut that, it will look like this. Okay? So we have DC, BC, and the 40 kN that it carries. Okay? Now, once you cut it down here, the next thing you should know is the angle because that will be used para masolve na to si DC and BC. So the angle here can be solved using tangent. Okay, we have a given na 2 here and then adjacent na 4 meters total. Okay, wala man tayo hypotenuse, so solve for ta sa tangent ato magamit. So 2 over 4. Some of you guys might have solved it using here. So 1 ni siya diri katunga man na 1 over 2. It's the same thing. So mine, tan theta akong gigamit is equal to 2 over 4. Arctan, we will solve for the theta, which is 26.565. Now, once you have the theta, the next step is, of course, we are now going to use the summation forces of y and x. Now, before we actually dig into this, let's visualize because, truth be told, some of you guys have a hard time identifying unsa mga forces along the y and along the x-axis. Now, kanimangod sila, this is very basic. Pinaka foundation ni of engineering, and I know nga medyo lisod-lisod yun atong time pag kung sa tawag ni online classes, but yes, kailangan ta mo review ani kay mo ni pinaka basic and foundation sa atong engineering. So going back, okay, before ta mo solve ni x, dapat mo solve sa ta ni y. Y. Ngano man, if you analyze here, the given nga naay value nga nagoy numero is actually 40 kN, which happens to belong sa y-axis. So we are going to use that. Kaya sa BC, wala kay ipares. Si DC, puro sila unknown. So we are going to solve sa atong y-axis, which is kaning DC o kaning 40. Okay, but before that, let's visualize. Adto ta dere. I know, not that one. Okay, dere. So I have drawn again the na naman tayo theta, no? 26.565. This is DC and BC and the 40 kN. Now, to analyze this, we need to dissolve DC. We need to convert DC into its components. Kaya kanang DC gatakilid man na. So kailangan nga ma-convert na siya into its components, which is dcx and dcy, which looks like this. So ang dc mo ni siya si dcy o dcx na. Kani siya i-combine na kay resultant nga dc. So makita nimo kailangan siya ma-dissolve they ma-convert into dcx, which belongs to the x-axis, and dcy nasa y-axis using the theta here. Now, if you are going to move this, i-move nato ni, this will look like a triangle na tawa. Ako na i-move. Triangle na with the same theta. That means to say, kana day si dcy, if you look at here, with respect to dc dc, hypotenuse, sa to pa si dcy is equal to dc times sine theta. Okay? Nakita ninyo? Opposite over hypotenuse. Kung opposite gani, sine ang gamiton. So that is dc sine theta. Kung multiply gani kag sine sa dc, sa to pa mo gamay ang value, that will result into its component. Inana ang another way of showing it. Same thing sa dcx. dcx is equal to dc cosine theta na po. Cosine na itong gamiton because it's in the adjacent side. Adjacent over hypotenuse. Hypotenuse ang ato ang dc in this case. Okay? I hope sabtan. Ato ni sang ilisan ha kay pasinyag ng libog theta. Okay? Something like that. Now, we will now incorporate this kana siya. Ako sa iuli ni siya. I-incorporate nato ni silang sa ato ang figure ganina. So, kung itaod na mo na, neat nato na siya, it will look like this. Okay? Diba? Ang katong DC, kani nga DC, gi-erase nato, gilisan nato siya og duha ka red. Muna na siya. So, it will look like this. Now, before I forget the kana mga arrows there, gi-assume ra na siya. This is an assumption. Nga ato ang mga forces along DC and BC are tension. It doesn't make nga kana silang duha tension automatically. Assumption na siya. Which later on we will find if tension ba siya really or compression. Going back sa atong figure, so since ang DC gi-erase na nato, gilisan nato siya og DCY and DCX which is here. Mo ni siya ang DCX ha. Kaning naa dere. Okay? Kani siya ang DCX. We will now solve for the unsay tawagan ni the EFY. Okay? Kaning EFY. So, ang EFY nato is basically the summation forces the disregard na siya. The summation forces along y-axis, which is this one here. DCY og 40 kN. So, kana ran duha ang ato ang characters. Ayaw nag-apila si kinsa pa nang ipa-apil mo diha. Kana ra, ikaw ra og ang imong uyab. Okay? Kung tulo na mo, kabit na to siya. Anyway, so EFY is kaniran duha, DCY and 40 kN. So going back sa ato ang figure, so we have DC sine theta, DC sine theta, sine 26.565 minus, since opposite man nilang kuan ha, positive ang tension, minus ang compression. I don't know. Later on pa na, later on. Ako pasabot is, ang atong direction is positive kung upward, negative man siya sa opposite man siya. So that means DC sine theta minus 40. So minus 40. Okay? Plus nito, minus nito. And that will equal to 0. Summation Fy is equal to 0. So DC sine theta minus 40 is equal to 0. Imo ni siya i-transpose, divide it by sine theta, or you can just, shift solve and solve for x. And you will solve for DC, which is 89.443. Okay? So, nanakay DC. Nanakay DC, BC na lang. So, since nanakay DC, we can now be ready to solve for BC along x-axis man ang BC. Going back sa figure, nanakay DC, di ba? So, kani siyang DC dire, pwede na siyang ilisan o figure. And notice nga, puro siya na dito sa left side. Okay, pwede ta mo assume nga, puro left side is positive. Depends upon you. Pwede rin na siya. Doesn't change the facts ato ang figure. Okay, so we have DC cosine theta ug BC. Puo sila ran duha ra gyapon. That means to say, sa ato we will have DC cosine theta, this one, kaning red, DC cosine theta, plus, kay same sila og direction, plus BC. Okay, BC. And equal to 0. Diri, nakabantay ko, naglibog yun mo diri. Kaya inyong gibut nga cosine theta si BC. I don't get nganong i-cosine theta ninyo si BC nga obvious man nga si BC gahigda na siya paingon sa x-axis. You know, BC doesn't have components. Walay y si BC. BC is just BC lang siya. Kaingon sa x. Okay? So wala siya itaon. Si DC noon ang may component. Okay. So going back here, so we have DC cosine theta plus BC. Substituting DC, nanamatay DC, di ba? 89.43 times cosine 26.56 plus BC is equal to 0. BC will now be equal to negative 80 kN. Unsay pasabot nga negative siya? Sato pa sayop inyong assumption nga tension. Irisa ang negative and you convert BC is actually equal to 80 kilonewton compression. That means to say the force, the actual load that BC is carrying is 80 kilonewton. Okay? Now, since natay 80 kilonewton, okay. So, ready na ta mo solve for actual compressive stress. F actual is going back, akong ingon, the load in BC over the area gross. Uy, di ba wala pa mo na area gross ka-solve? Pero we know, kabalo taon sana pag-solve. Okay. So, for area gross, ari ta sa itong figure. Okay. Now, the question is actually, ningon siya dito nga, we have a tubular diameter nga 50 ang outer, and naapod tayo thickness nga 10 mm. So 10 mm ang nastaas, 10 mm po ang sa ubos. That means to say we have, actually di na given ha, that means to say we have an inner diameter which is 30. Okay? 50 minus 10 dire, 30 ang tunga. So sa donut. So we are tasked to find the area of the hollow, kaning sa hollow, kaning deres tunga. Oh, kanarang shaded part. So, ang area of the ana is just equal to the area sa tibuok nga circle, nga 50, minus nimo og area sa tunga, kanang 30. So, ang mabilin, kanig yung na dire. Sakto, nakasabot. Okay? So, manually, we can, get the area here, and then minus, na nakay, masolve. But the other shortcut for here is kanang pi over 4, pwede na nimo na siyang kuan kaning unsa tawag ni common factor man. So pi over 4 is times 50 squared minus 30 squared and you will get the area which is 1256 millimeter squared. Now, since you have the area already, substituting values 80,000 na imo ibutan diri. sorry. Okay. 80,000 ang imo ibutang dire divided by katong nakuha nimo nga 1256.637 millimeter squared and you will get MPa 63.62. MPa is Newton per millimeter squared. 80,000 imo gamiton dire. Okay? So that's it for question number 1. Now, let's go for the number 2 question, which is, let's find the allowable compressive stress of member BC. Actually, I'm happy that I think all of you got this because this is a procedural. Ang problema lang ani is if sayop ang imong K nga gigamit or if sayop ang imong formula nga gigamit. Kay lahi ang formula for long column and short column. But the procedure is very the same. Okay? Sige, atong hinahinayon. Going back, so we have this figure here, and we have R, and we also have the Fy. Now, to find the allowable compressive stress of member BC using ASD, okay, we need to analyze this part lang. This is 2 meters. And this is pin connected. Kaning dire. Pin po niya siya. But ang pasabot aning sa atong figure, pinning dire. Kaning sa point B and point C. Okay? Pin yun na siya basta inana. Unless otherwise stated. Okay? Now, very procedural. Katatong gina-solve always. We have the allowable compressive stress. First, solve for the slenderness ratio. Okay? The slenderness ratio is KL over R. We have K is 1 because these are both pinned. And we have 2 meters lang kay BC ratong i-analyze. That is 2,000 meters. Kani? Divided by the given nga 14.58. And you'll get this slenderness ratio. Next is we solve for CC. This is used to compare if long ba or short ato ang this figure, ato ang section. So CC is 4.71 square root of E over Fy. If ang E is not given, it is automatically, yes, correct, 200,000 MPa or 200 GPa. divided by Fy, which is 290. Okay? So, is equal to 123.691. Comparing values, if i-compare ni mong SR and CC, if dako ang SR, automatic long na siya. But wait, there's more. Okay? Okay. Pwede nato na siyang i-check if doon bang long. Kay tendency ana, nasipyat mo. Muna siya purpose niya. Later on. Ato ikon ha. Sige. So for now, nasolve naman nato. SR is greater than CC. 123 man na. 137, 123. So, elastic buckling ang experience ani, and this is a long column. Now, let's solve for FE. Pi squared E over SR squared is equal to kani, nanakay pa, nanakay E, and we have SR already, 137.174. Substituting values, we get the FE, the effective stress, 1 over 0.902. Now, muna akong pasabot. Let's check. Kung ang 0.44 gani, Fy, is greater than Fe, sa to pa, tinuod nga long yun ang imuha. Okay? Long column yun. So, substituting values lang, 0.44 times Fy 290, we have 127.6. Yes, it is greater than the 104 ng Fe. It is really a long column. Now, kani, kung mahitabo nga sipyat mo og K dire, like let's say 0.7 yung gigamit or 2, na tendency aning dili mo magkaigo dire. So, matingala ka ba? Hala, long dire niya. Pag abot sa checking kay short, oh, there's something wrong with your solution. So, you have to review. Okay? Kay daghan kayong nasipyat sa K. Once sayup ka sa K, sayup na ni tanan. Okay? Useless na tanan. So, be careful. If maguba ng trust, wala na. Toxic na and wala na yung hope. Okay? So, going back, since it is long, correct na siya. It really is a long column. Now, so use the FCR for long column. Kaya ang uban ra ba, sus ko, di mao ang igamit, dili na maunang dire. 0.658 tong sa short. Kanin dire 0.877 times FE, you have the FCR. And since you have the FCR already, you can now solve for the allowable compressive stress. Ang FCR nato is basically muna atong pinaka-critical point, muna pinaka-maximum. So, for the allowable, ato nang kuhaan with the factor of safety nga 1.67, 92/1. So, ato ang allowable compressive stress is 55.09 MPa. Okay? Alright. Now, let's ready na tayo solve for the design strength of member BC for LRFD. Now, the design strength, so kung yung design strength, meaning ang load. Okay? PU, ato ang gisolve ani. Kay LRFD man. Okay. So, since we have the FCR na nga, 92 MPa, we can solve that. We can use that value. Now, I am presenting you two solutions. The first solution is this. Kanang relationship sa FCR o kanang sa allowable or sa design stress, mura na nagitauran ninyo og factor of safety. Now, since we are using LRFD, we have the ultimate stress is just equal to phi times FCR, which phi is 0.9, di ba? 0.9 man na. Okay. And FU is, we know for a fact na PU over AG na siya. Which is, kanina itong gi-find out, PU over AG. AG transfer here. So we have PU is equal to phi FCR AG. And 0.9 substituting values, 0.9, 92, 1256. And we have PU 104. Another way of solving this is, let's solve for DPN, the nominal load. Nominal load is just equal to FCR times AG. Okay, we have 92 times area, gross nato is 1256, and we have the nominal load which is 115.610. And then, tauran na nato siya o factor of safety nga 0.9, which is the phi for PU, and we will arrive at the same value. So, depende ninyo unsay mas preferable ninyo, but sa akong part, actually kani mo mas preferable kani siya. Pero at least you know nga, pwede din siya ning shortcut. Okay? Yeah. For number 1, that's all. And for number 2, actually, di na ako kaila i-go through kay I'm happy nga na-solve man ninyo ni. Ang uban, wala ka-solve because sayop ang K. Pero I've gone through your solution. Sakto ang yung pamaagi, sakto gyud ang kuan. Sayop lang ang values nga gi-input. So you arrive at the wrong answer. Okay? So K nato ani is 1. Ano man mo ni ibutang og 0.7? Wala jud ko kasabot. Pinned ends. Okay? Nadari ang hint. So, muna siya yung pinaka-purpose. Ganun ni ibutang ko og given, di ba? Ayaw mo og diretso gira. Ayaw mo diretso atake. Write down the given. Are you sure about the given? So, magsulat mo ani og given. Ang ako ibutang ani is, we have the L nga 6,000 millimeter. We have K nga 1. And, FY nato kay wa man gihatag is A36 still. Okay? Nanata FY, di ba? Dapat. You should know about that. And FU, di na needed na FY lang. So, kana, ipang sulat na nimo. Okay? So, muna siya itong answers. Inana. Recheck lang or resolve lang sa inyo. Inana. If you arrive at the same answer. Okay. For number 3, basically, it's the same as number 2. Medyo sakit lang sa mata, kay na-figure, and dagan kang given. Dagan kang given, nga K, napunta ari, A, D, F. Now, solving this, unsay RX among gamiton, sir, or R nga among gamiton. Ang hint ani is actually sa given. IX ray gihatag. So that means RX ato is solved po. Okay? Now, in getting RX, nakoy hint diri for built-up section, so we need to get the total I. And A. Solving this. So R is equal to square root aning I over A. Atong ikuha aning 2 na diri. And I nato is equal to 32.7 times 10 to the 6 times 2. Kay duha man na. I-divide na nimo sa area nga 3780 times 2 pod. Okay? And you will arrive at Rx nga 93 mm and solve the SR since na kay Rx, solve for FE, solve for FCR. Ayaw kalimuta, K na to is 2 for SR. And you will arrive at PU and PA nga 602. I hope that helps. I-review lang ninyo. Thank you. And sige, let's go sa ato ang special exam. Okay? Sige. So sa special exam, chance naman ta ni kaayo ninyo kay open notes and you have all the time to solve for this. Sige lang. Muna siya ato ang solution for this. Determine the adequacy means, is it safe or not? Unsa may pasabot o adequate ba siya? Or unsa may pagsabot nga safe ba siya? This question, safe na siya if ang design PU is greater than PU. PU akong ikuanan ni kay naman go dere yang giingon dere is used to carry an actual dere. Kani nga steel column is used to carry. Nana siya basically it's the actual load that it carries. Mo ni siya 623 o 1868. PU gyapon ko magibutang kay hinumdum mo sa first nato nga topic sa LRFD PU is equal to if dead load and live load that is 1.2 DL plus 1.6, correct? Okay. So, actually, pwede kang ASD imong gamiton ani, but ang andan na to karon is LRFD gyud and mas economical pong LRFD. So, mag-anad na mo inanat. You can solve for ASD po. Ang tawon ni safe ba or not. Pero LRFD ang atong solution karon. Okay. So, safe na siya if ang design PU kanang imuhag yung maximum allowable PU gani. Okay? With kuan na siya safety factor should be greater than the actual. Siyempre, og dili maka og mo dako pa ang actual, mabungkag na or mabali ang imong column. Okay? So, muna siya yung pinaka-idea niya. So, sa ito pa, used to carry na, the column is 9.4, pinned at top and bottom. Pinned ha? Okay. K is 1 na dayon. Determine the adequacy. So, ang atong pangutanan is, adequate ba ang column section? We have FY345. So, ang atong pinaka point is, we need to solve for the design PU. Then, yung i-compare nato na sa PU nga 6231868, i-combine pa na nimo using 1.2 DL plus 1.6 live load. Sige. And we also have the given here, na mga given. Okay. Alright. Sige, start na ta. First is, you write down the given. 345 ni. Nasa yup ko ni. Isa ako say change ni be. Sa yup. 345. Okay. Alright. So, we have Fy, which is 345 MPa. And next nga itong makuhaan ni is, which R atong gamiton? Now, kung kamo gani guys, mag-solve mo ani niya, wala agingon nga naay brace ato nga, automatically, ang inyong pilion nga R is katong mas gamay. Okay? Ug wala gani mo kon sa tungaan ba? So, di na nimo na i-investigate ang RX o RY. Automatically, ang weaker. So, ang gamay. Since makita nimo sa given, wala siya R dire, di ba? Instead, ang naan dire is actually, wala din na yung RTS lahi na. Ang gihatag na is IX o IY. And we all know for a fact na ang R is equal to the square root of I over A. Na may A dire. Okay? So, asa aning duha? So, syempre, ang lesser nga I ang atong gamiton, kay mo na yung muhatag og lesser nga R po. Okay? Si IY atong gamiton. Since lesser R is needed. So, square root of IY, 228.095 divided by, times 10 to the 6, divided by 24, 25,032. Inana lang ang ato ang kuan, idea. Ayos ay solve. Sige lang. At least kabayo na ka nga na ay inana atong pamaagi. Okay, so let's go sa ato ang solution. Okay. Since unbracement is both, again, sa weaker axis ang mo govern. So, slenderness ratio is equal to KL over R. We have a K nga 1, again, pin both ends. And 9,140 man to ato ang length, right? Square root of I over A na siya. And we have 95.75. Checking sa NSCP 2015, dapat less than 200 na siya. Actually, so yun na. Checking lang na siya. Mostly sa mga problems with less than 200. Sir, say may tabog mo more than 200. Dili ideal ang imong gigamit ka section. Sugod pa lang hagbong na. Okay. Okay, sige. Next is, once you have KL, you have the slenderness ratio, ato siya i-compare ni CC. Di ba mo ni si CC? Okay. Si CC is 4.71 square root of 200,000 divided by FY na to 45 ya. So 113.4. I-compare si 95 o 113. Kinsay mas dako? Yes, mas dako si 113. Kung mas dako si CC, automatically kana siya short column na siya. Okay? Pwede po nimo na i-check. I-check po na ito na later. Ha? FE katong 0.44. Pwede na ito na siyang gamiton. So since dako ang short column na siya, and we will going to hold on. Wala pa ta ka-solve sa FE. Oh, okay. Na there is FE. Kay ang FCR nato is 0.658 FY over FE, di ba? Mo nito gamiton for short columns. So FE is equal to pi squared E over slenderness ratio, di ba? Masolve na ninyo, that's 1.5. Kung mas dako si FE kaysa 0.44 FY, which is 151, tinuod nga short column gyud ninyo ha. Mo na itong checking. Okay? So substituting values to 1.5, tawag na nimo diri, and FY here, you will get the critical stress, which is 176.42. Kana is-substitute na ito sa atong PN, nominal load, 176.42 times area gross nasa atong given, 25,032. That will resolve into 4,416 kN. Gidivide na siya daag 10 to the cube or 1,000 para ma-kN. Okay? So, mana na siya. Since you have the nominal load already, times na to siya og phi to get the PU. So, we have 3974. Since na kay PU nga 3974, let's compare it to the actual load nga na dito, which is 1.2 dead load plus live load, 3736. Sus, dugol-dugol ra kayo, no? Pero, mas dako man gyapon ning sa to pa, safe ang imo column. Okay? That is safe. Okay. Post lang dayong if medyo paspas. Sige. Let's go sa hold on. Wala na. Ay, number 1 ra lagi to.